Match problem 2 gives us two more examples to take a look at here. Again, applying these properties of differentiation with exponentials and log functions. So we start off in part A with the derivative of a log function, making this 30x squared minus 100, which is just a constant multiple, so that just comes down unaffected by the derivative. And then we need to differentiate the natural log of x. So the derivative of the natural log of x is just going to be 1 over x, and that's our final answer. Or alternatively, we could rewrite this as 30x squared minus 100 over x, or 30x squared minus 100 x to the negative first. So all three equivalent answers there. In part B, we're still dealing with the derivative of natural log and exponential functions. But in this case, we're going to need to take advantage of some properties of logarithms in order to be able to differentiate this function. So here what we have is the natural log of x to the fifth. So the first thing we want to do to simplify this problem is get rid of that exponent. So properties of logs allow us to bring that exponent down as a factor in front. So that looks and sounds similar to our power rule for taking derivatives, but this has absolutely nothing to do with calculus. That just goes back to some basic algebra skills. So if we're taking the natural log of something raised to a power, that exponent can come and drop down as a power in front, and now we're just taking the natural log of just that something, in this case x. E to the x we don't need to rewrite. We can differentiate that exactly as it is. And then here we have minus the natural log of e squared. So this is going to be 2 times the natural log of e. So without doing any calculus, we've just rewritten that problem to simplify it a little bit and make our derivative process a little bit easier. So now 5 is just a constant multiple. So we need 5 times the derivative of the natural log of x, which is going to be 1 over x, plus the derivative of e to the x is e to the x, minus 2 times the natural log of e. And again, what's important to pick up on here is that there are no variables in this expression. So 2 is a constant, e is a constant, taking the natural log of e is still a constant, in this case actually 1. So the derivative of a constant is just 0. So our final answer here would be 5 over x plus e to the x.